The enormous dark smudges that form in the atmosphere of the far-off planet have long baffled astronomers. They first appeared when Voyager 2 passed by Neptune in 1989. Now, for the first time, we have examined one with devices based on Earth in an unparalleled resolution, aiding scientists in understanding why those patches appear to be so black and why they differ so greatly from spots on other worlds. Since the first black spot was seen, astronomer Patrick Irwin of the University of Oxford in the UK said, "I've always wondered what these transient and elusive dark features are. I'm overjoyed to have been able to record a dark spot's reflection spectrum for the first time as well as make the first detection of a dark spot from the ground." The Great Red Spot on Jupiter and Neptune's dark vortices are both anticyclonic storms, yet they differ in a number of significant and enigmatic ways. They appear and disappear every few years, making them rather transient. At comparison to the storm vortex on Saturn and Jupiter, they are also expected to have less cloud at their centers. The fluffy white clouds that we can see are likely caused by gases freezing into methane ice crystals as they are transported upward from lower altitudes. But it has been difficult to understand anything more because of Neptune's distance and the vortices' transient nature. The only telescope capable of monitoring and tracking them since 1994 is the Hubble Space Telescope, which restricts the range of wavelengths in which the planet may be viewed. But in 2018, Irwin and his team had the opportunity to use another tool, the Multi-Unit Spectroscopic Explorer, MUSE, of the Very Large Telescope. By separating the sunlight that was reflected off of Neptune into its individual wavelengths, MUSE was able to create a 3D spectrum of the planet. The researchers were able to determine the altitude of the black patch by using the fact that different wavelengths correspond to different elevations in Neptune's atmosphere. Unexpectedly, they discovered that it wasn't actually a hole in Neptune's atmosphere after all. Instead, a darkening of particles in the layer of hydrogen sulfide beneath the top layer of Neptune's atmospheric aerosol haze appears to be the cause of the deeper color. The reason for this, according to the researchers, could be local heating in a deep anticyclonic vortex that vaporizes the hydrogen sulfide ice to show a darker vortex core. The researchers' findings are consistent with the idea that as the particles in the aerosol layer above get smaller, opacity decreases. Another unexpected discovery was a brilliant cloud that was nearby the vortex. This was a different kind of cloud from the usual methane clouds that accompany Neptune vortex. It appeared to be at the same altitude as the dark vortex, not higher in the atmosphere. Further research will be required to determine what this is and whether the team's suggested processes for Neptune's atmospheric darkening are accurate. However, now that it is possible to observe Neptune from the ground, we appear to be much closer to finding the solutions. According to astronomer Michael Wong of the University of California, Berkeley, this is an astounding improvement in humanity's ability to observe the cosmos. Initially, the only way to find these places was to send a spacecraft there, like Voyager. Then, with Hubble, we were able to see them clearly from a distance. Finally, this is now possible from the ground up thanks to technology. The study was made public in Nature Astronomy,